So so I told you my son is engaged to be married. So he and his fiance were here for the week between Christmas and New Year's, which was wonderful. But his fiance is starting a new job today as a teacher, same school that he's working in. She's going to be teaching science to 7th and 8th grade. And she's never taught before. She majored in biology in college, and thought she wanted to go to medical school, but then after working in a chiropractor's office for a couple of years, decided she didn't want to do that. So she's kind of like, I'm not sure what I want to do. But anyway, she's starting a new job as a teacher today. And she's scared to death, absolutely scared to death of these little 7th and 8th graders. And it just brought back a lot of memories of when I started teaching and that feeling. I mean, if you can just imagine yourself going into a classroom with a bunch of 12-year-old children and teaching them for the first time, like, how do you do that? So it was good to reflect back on what it was like that first year of teaching and the first time walking in a classroom, not knowing what to expect, because it also reminded me of things that I've kind of lost track of. Like now that I've been teaching for so long, it's just automatic, and I've kind of lost track of it. And some of the things, I was like, man, I should be doing that, and I don't do that anymore. So my son and I were helping her. We were actually helping her with her lesson plans, and then at one point, we even modeled a lesson for her. It's like, okay, I'm going to model this lesson. I was like, okay, I'm going to be the teacher. You're going to be the students. And we modeled that. And it was a great exercise for me, even though we were doing this to help her. For me, it was a great exercise because I was like, oh yeah. Because I was trying to remember to do all these different things that you should do, especially with 7th grade students. 7th graders are a whole breed in themselves. They're like, okay, first off, 7th grade boys are the stinkiest beings on the earth. I'm sorry, 7th grade boys are stinky. They really, they don't understand their human bodies. So it's like 8th grade, they start to understand it, but 7th grade, oh my word. And 7th grade girls, the cattiest girls on the face of the earth. Holy smokes. So that's like 7th. I hate teaching 7th grade. Let me just tell you right now, I hate teaching 7th grade because of that. So there's a lot of things that you have to do in 7th grade with 7th graders, with 12 and 13-year-old kids that maybe you just take for granted in high school. But it was a really good reminder to me. But if you think of it during today, just pray for her. She's trying to do something, and she wants to be an outstanding, excellent teacher, and she's working with these young minds, and that's a scary thing. So if you think of her during the day, please pray for her. Her name is Elizabeth. Okay, so we are looking at exponents. So let's look at some basic rules first, okay? Just a refresher. So if I have 4 to the 3rd, what does that mean? There you go. 4 times itself 3 times. Yes. Okay. And just as a reminder, this number 4, this is called the base. And this is our exponent, right? Now, if I have 4 to the 3rd times 4 to the 2nd, okay, what's actually happening? I have 4 times 4 times 4, right? There's my 4 to the 3rd, times 4 to the 2nd, so 4 times 4. Everybody with me? How many times am I multiplying 4 times itself? 5 times. So we can write this as 4 to the 5th. Now, we don't typically do that. We don't typically write it out longhand like that. What do we do? What's the shortcut way? We add the exponents. Okay? So when we are multiplying numbers that have the same base, we add the exponents. You should be copying these examples down in your notebook, please. There's one thing you should have learned at the end of the first semester, that some of you did not have notes to refer to in order to prepare for your exam. You should be writing this down. Everybody should be writing it down. Okay, so when we are multiplying two numbers that have the same base, we should be adding the exponents. Okay, so what if I had x to the fifth times x to the third? Do they have the same base? Yes. So what do we do with the exponents? Add them. So this becomes x to the eighth. Okay. Okay. How about, let's do a to the sixth times a to the fourth times b to the second. What do you think that's going to look like? Right, I'm just adding the exponents for the a's. So this becomes a to the 10th, b to the second. I'm only adding the exponents with the a's on it. Okay. Okay. How about a to the third times a to the fourth times a to the fifth times a to the sixth? Are they all the same base?
Yes.
Yeah. So what are we doing with the exponents? Adding them. I don't need a calculator because I know the 4 plus 6 is 10. And then I've got 3 plus 5 is 8. So 10 plus 8 is 18. A to the 18. Okay. Okay. Let's get a little bit harder. Let's do 3x squared y to the third times 4x squared y to the fourth. Okay. Some of you can do this right away, looking at it. But for those that don't see it right away, we're going to group our like terms. So I'm going to rewrite. This is all multiplication. It doesn't matter what order we multiply. So I'm going to change the order. I'm going to do 3 times 4 times x squared times x squared times y to the third times y to the fourth. Right? It's all multiplication. So I can just rearrange it and put my like terms next to each other. And that makes it easier to see. 3 times 4 is 12. X squared times x squared is x to the fourth. Y to the third times y to the fourth is y to the seventh. Adding the exponents. Right. Yeah. You should be writing all these examples in your book, in your notebook. All of these examples should be in your notebook, Ronnie. You have them all in there? Even that last one? Good job. Okay. Okay, I'm going to have you do one of these on your own. Let's do, let's do 2a to the third, b to the second, c times negative 3, a to the fourth, b to the negative third, c to the fifth. Okay, try that one on your own. Okay, so I start off by grouping them together, put my like terms together. Remember, when parentheses are next to each other, that means multiplication, okay? And the only reason I'm using the parentheses is because of the negative signs there. All right, so 2 times negative 3, that gives me negative 6. What's a to the fourth times a to the third times a to the fourth? A to the seventh, good. And then we have b to the second times b to the negative third. B to the negative 1, good. 2 plus negative 3 is negative 1. C to the first times c to the fifth is c to the 6. Okay? Okay. There's only one last thing we're going to do, and that is deal with this b to the negative first. Does anyone remember what we do when we have a negative exponent? No? We're going to move it. We're going to move it, right? So we have negative 6. Remember, this is all over 1, right? We assume that's over 1, right? So we have negative 6, a to the 7th, c to the 6th. This b to the negative 1 needs to be moved. Since it's on top, we're going to move it to the bottom. B to the first down there. When you move it, it changes from negative to positive. So for instance, if we had, let's say that we had x squared over y to the negative third. In order to change that to a positive exponent, I would move it, in this case, I would move it up. So this would become x squared y to the third over 1. So you move it to make it positive. If I had a to the fifth, b to the negative 6, how would I rewrite that so that the exponent was positive? Exactly. Okay, and it becomes positive. All we do is move it. Okay. Okay, so we know how to multiply. How about dividing? Right, so if I have a to the fifth over a to the third, okay, let's just explore what happens with that. That is a times a times a times a times a over a times a times a. Okay. In this case, the a's cancel. Does everybody understand that?
Yeah.
Okay. Okay, so just think of it this way. Let's say that I had, let's say I had 4 over 2, right? And I rewrote the 4 as 2 times 2 over 2. Okay with that? These 2's will cancel, leaving me with just 2. Well, is 4 over 2 actually equal to 2? Yeah. So if we're multiplying, this is really important, it has to be multiplication. If we are multiplying, then we can cancel if it's the same number on the bottom, right? If it was plus, like, let's say that we had 6 over 2, right? So we had 2 plus 2 plus 2 over 2. 2 plus 2 is 4, plus 2 is 6, right? Now we cannot cancel. If we cancel, we end up with 4, and that's not true. So it has to be multiplication. If it's multiplication, then we can cancel the top and the bottom, okay? So here we're looking at those a's all canceling out, leaving me with a times a, which is a squared, okay? The shortcut, just like with multiplication, we add it. When it's division, we subtract. Oops. So we would have a to the 5 minus 3, which is a squared. It's always the top number minus the bottom number. Okay. So let's look at x to the 8th over x to the 3rd. What's that going to equal? X to the 5th, right. 8 minus 3. So we get x to the 5th. Okay. What about, let's do p to the 2nd over p to the 5th. Remember, it's always the top minus the bottom. So this is p to the 2 minus 5, which is negative 3. Now, how do I rewrite that, making it positive? 1 over p to the 3rd. Move it, right? This is on the top. Move it to the bottom. Okay? Now, here's a little trick that I use with this type of problem. Right? I have p to the 2nd over p to the 5th, all right? And I'm just going to write it out the long way just to show you. Okay. So what happens with the p's? They cancel, leaving me with just, right, they cancel. It's not a 0. It leaves me with a 1 on top. And how many p's on the bottom? 3. Okay? So the trick that I use, right, I subtract them. The answer goes wherever the larger exponent is. So I always subtract the small number from the larger number. 5 minus 2 is 3. And the answer goes wherever the larger exponent is, because that's where they're going to be left, right? So if I have x to the 10 over x to the 12, right? 12 minus 10 is 2. And where's the answer going to go? In the bottom, because the bottom's where the larger exponent is. So this will be 1 over x squared. Okay? Another way of thinking of it is there are 10 x's on the top, right? These 10 x's cancel out 10 of these. If I were to write all my x's out, right, the 10 on top will cancel 10 on the bottom, leaving me with 2 on the bottom. Okay? If I have a to the 20th over a to the 15. Okay? 15 of the a's will cancel, leaving me how many? 5. And they'll be on the top. So there'll be a to the 5th over 1. Does that make sense? Okay, let's take it a step further. Let's see here. Okay, how much time do I have left? Oh, got lots of time. I heard the noise. I thought the period was coming to an end. Okay, let's do x to the 3rd, y to the 6th, z squared over x to the 8th, y squared, z to the 5th. Okay, now we just got harder. Just got harder. Okay, so what I'm going to do, I'm going to rewrite this grouping my like terms. So I'm going to write it as x to the 3rd over x to the 8th times y to the 6th over y squared times z squared over z to the 5th. So I separated them all. Now we're going to work with each piece. So now it's the same thing we were doing up above, right? Nothing different. Okay, x to the 3rd over x to the 8th. Where's my answer going to be, on the top or bottom? Bottom, okay. So on the top, I'm going to have a 1. How many will be left in the bottom? 5 of them. So this is x to the 5th on the bottom. 8 minus 3 is 5. Since the 8's on the bottom, it's larger. My answer is going to be on the bottom. Does that make sense, Yana? Okay, think of it this way, all right? Think of it this way. I have 3 x's on top, x to the 3rd, and then 8 on the bottom. 4, 5, 6, 7, 8. X to the 8th on the bottom, right? Those cancel, those cancel, those cancel. How many are left down here? 5 of them, okay? Okay. They updated this program, and I don't like the eraser. It's really weird. Okay. How about the y? What's left with the y? Left on the top. 6 minus 2 is 4. And they're going to be on the top because there's more y's up there. Y to the 4th over 1. Z, right? They're going to be on the bottom because there's more z's on the bottom. 5 minus 2 is 3. So it'll be z to the 3rd. Please make sure you're all copying this example down. Okay. Okay. Now we've worked with each one. All we have to do is we're going to draw a line straight across, because when we multiply fractions, we multiply straight across the top. 1 times y to the 4th times 1 is y to the 4th. And on the bottom, we have x to the 5th, z to the 3rd. Okay, we separate them, and then we bring them back together. Okay. Separate them, and then we bring them back together. Okay, let's look at another example. Let's look at 6 a to the 2nd, b to the negative 3rd, c to the 4th over 2 b to the 6th, c to the 1st. Okay. Okay. So what are we going to do first? Separate them and then bring them back together. Okay. So we're going to separate them. So 6 over 2 times a squared. Is there an a on the bottom? No, so it's just a 1. Times b to the negative third over b to the 6th times c to the 4th over c to the 1st. Okay, everybody should be copying the example down. Okay, so let's see, do we know what 6 over 2 is? 3, yeah, so that's 3. I'm just going to say over 1, right? 3 over 1. We have a squared over 1. Okay, now the b, I don't like that negative, so what can I do about that? Bring it to the bottom. So this becomes 1 over, we have a b to the 6th down there. I'm going to bring the b to the 3rd down. Times, what happens with c to the 4th over c to the 1st? C to the 3rd on the top. Okay. So all I need to do now, 3 times a squared times 1 over b to the 9 times c to the 3rd. We draw our line straight across, and we're left with, on the top, 3a squared c to the 3rd over b to the 9. Okay, we separate them, then we do some work with them, and we bring them back together. Okay, when my son came this Christmas, he has a 9-month-old golden retriever. What's the mix? I can't remember the mix, but really, really, really big dog, bigger than my dog. My dog is a golden retriever. She's 8 years old, and this dog's 9 months old, was bigger than her. So, right, they got when they got here, their dog, they have absolutely no control over their dog. She's just like all over the place. So we tried to keep them separate. They just kind of like got together, and it was not successful. My dog was very upset, growling and barking, So what did we do? Separate them. Okay, I took my dog, took her over here, settled her down. They took their dog over there, settled her down, got everything under control, right? So we separated them, got it all under control, and then brought them back together in an organized way. Okay, got them both under control with their leash, brought them back together, let them sniff and growl and all that stuff at each other, right? So what are we doing? Right, we're separating them, right? Separating them, get them all under control, and then bring them back together. Okay, everybody got that? Okay, let me let you do one of these by yourself. Let's do -2. X to the 5th, y to the 2nd, z to the -3rd over 8, x to the 2nd, y to the -4th, z to the 2nd. Okay, you're going to try that one by yourself. You're going to separate, get each one under control, and then bring them back together. Okay, so we're going to separate -2 over 8 times x to the 5th over x to the 2nd times y to the 2nd over y to the -4th times z to the negative third over z to the second. So I'm separating them. Now I'm going to try and get them under control. So I'm going to work with each one separately. What is negative 2 over 8? Negative 1 over 4 times x to the fifth over x to the second. What's that going to leave me? X to the third. Is it on the top or bottom? Top. How do we know it's on the top? The top has more. There are 5 x's on the top and there's only 2 on the bottom. Top has more, so that means they're going to be left on the top. So I'm going to just do x to the third over 1 times. Now, how do I handle this y to the negative fourth? Move it up, because it's a negative exponent. Move it. It comes up top. So this becomes y to the second times y to the fourth up there. Okay? And then what happens with the z's? We move them down. Right? We've got to move those negative exponents. So this becomes times 1 over z to the second times z to the third. Okay? Shayna, why did I move the z? Because it was a negative, exactly. But here's a question, Tori, right? So with the y's, I had a negative and I moved it up. With the z's, I have a negative and I moved it down. Why didn't I move them both the same way? Okay. Timesing what by 1? The negative? Okay. So, but if I multiply by 1, don't I just get the same number? So here, I guess, okay, let me rephrase the question, right? So if you look at that, both of them had a negative exponent, right? Ava, maybe you can help us, right? Both of them have a negative exponent. But with the y's, I moved the y to the fourth up. With the z, I moved it down. Why did I move them different directions? Right, one was on the top and one was on the bottom. We always move it the opposite of where it is. Okay? So if it's on the top, we move it to the bottom. If it's on the bottom, we move it to the top. Okay, let's finish simplifying this. Now I have negative 1 over 4 times x to the third over 1 times, what's y to the second times y to the fourth? Y to the 6 over 1 times 1 over z to the second times z to the third is z to the fifth. Okay, here comes the big step. Damien, what do I do now? Put it all together. Yeah, put it all together. Just kind of draw your line straight across. We have negative 1 x to the third y to the 6 over 4 z to the fifth. We separated them, worked with them, cleaned them up, and then brought them back together. Okay? Questions? How about a fist of 5? Good. Excellent. Okay. All right. I have a worksheet for you. This is homework, so you're going to start it now and finish it for homework if you do not finish. Okay? Don't forget, since it's homework, what can you expect tomorrow? Mini quiz. Okay, I'm going to take one of the homework problems and that will become your quiz.